Hello and welcome to this tutorial. My name is Mikkel and let's step into our factory of the future.
When following any tutorial, check the lesson on the Visual Components Academy, and if the Download Files option appears, you can download the example files.
In this self-training exercise, we're going to be creating the layout that you can see running in the simulation currently. And the goals of this exercise will be to first, of course, create the layout itself, so learn the basics of layout building. Then we'll go further and analyze the system to find any bottlenecks that it might have. And the goal of this exercise is to optimize our system so that we can go from the initial 50 production units to a final of 130 production units per hour. Okay, and the first thing you want to ensure is to, of course, have Visual Components open and ready to go. And what I also recommend you to do is download all the files attached to this tutorial, as we'll be using those in this exercise. And the first thing we'll be needing straight away from these files is the self-training drawing. So let's have this open. Let's unzip the file, and from the unzipped folder, we can drag and drop this self-training drawing into our 3D world. And this drawing will guide us in arranging the components in this layout. And at this point, I also recommend to get familiar with the navigation controls in Visual Components. We have three main controls here. So one for zooming, one for panning, and one for rotating. And at this point, I recommend you to try these out before we start the tutorial, because it makes it much easier for you to follow what I'm doing. So feel free to pause the video here and give yourself a few moments to try these out. And once you're familiar with those navigation controls, we can start to add components into our 3D world. And we'll be locating and finding our components from the electronic catalog here on the left-hand side. And for now, we'll expand using this triangle here, the Models by Manufacturer folder. And we'll head down over to the Visual Components subfolder and expand this as well. And all the components that you'll be needing for this exercise are located over here in the Visual Components subfolder. Now we'll take our first component from the electronic catalog into the 3D world. And for that, we need to locate the conveyors folder here. And I can expand this window a little bit here. If I go to this edge of this panel here, I'll expand this. And inside this folder, we should see the first component called conveyor. Holding down the left mouse button, we can drag and drop this component into the 3D world like that. Okay, and what we're going to do is we're going to locate all of our components above our drawing. And we want to orient ourselves in this direction here. If you want to find this orientation, you can click here on this line, which will orient us in the same position. Now, we want to position our components above this drawing over here, in this space above. And there's two tools here in the manipulation group that we can use for locating components. We can use the move tool, which is for more precise and accurate movements. But for now, the PNP plug and play tool will suffice. And this allows for quick and easy movements over our components. And it also allows us to connect components with one another. So let's make sure we have the PNP tool selected. And then I'll hover over to my conveyor here on the right-hand side. And you notice that with the PNP tool, we have this ring or circle around our conveyor. And if I hover my mouse inside this ring and hold down the left mouse button, we can locate our conveyor like this. Okay, so that's the conveyor now in place, but we need other components as well to create this layout that you saw in the beginning. So please go ahead and take these components here. So feel free to pause this video here and locate these components of the electronic catalog and place them above the drawing. And once you have your components in the 3D world, your layout should look something like this. And if you have trouble at any point in this video locating components, especially small components, you can go here in the bottom left to this thing called the cell graph. Cell graph. And in the cell graph, you can also select the components by name. Also, another tip is that if you accidentally close any panel, like for example here, and you want to reset back to the default panels in Visual Components, you can simply go to the very top right of the window and click on the Restore Windows button. And this restores the default view in Visual Components. At this point, I also recommend saving the file. So from the top left, click File, Save As, and then save this file to your own directory. In order to save your file, give it some name. For example, self-training layout like this. And then what I'll do next is I'll click on the Browse, and I'll save this file on my computer. And once you have your file saved, I'll show you how the final system will look like. So it will look like this. And the first stage in our flow or in our system will have a person collecting a lathe component from a shelf. And now I'll speed up the simulation a bit here, placing it onto the conveyor, an in-feed conveyor, which feeds it to our robot cell, from where the robot places this lathe comp into the parametric vertical mill, from where it goes to the CMM machine, and then it goes on the outfeed conveyor, from where the human in a moment will pick this lathe comp, work on it on the manual workstation, and then finally bring it to our sink here, which is the end of our process. So this is how the system will look like. So this is the goal in mind that we'll have. But before we can do any of this stuff, we first, of course, need to locate our components. And for that, we'll start with our parametric vertical mill. So let's select the parametric vertical mill. And with the parametric vertical mill selected, on the right-hand side, we can see the component's name that we've selected, so the parametric vertical mill. And we can see its component properties. And what we'll do now is we'll go in these component properties window to the dimensions tab over here. And we'll change the machine size from custom to small. And now we'll see that the appearance of our machine has changed. The next thing we'll do is we'll locate our machine at the right spot. Again, using the PNP tool for easy and quick movements, we'll hover over inside this ring, this blue ring, and holding down the left mouse button, I'm going to move my machine over here like that. Then we can move on to our shelf. And for this, we'll click on the shelf first. And again, we'll need to change some of its component properties here. So on the right-hand side, we can see that the warehouse shelf is selected. And we're going to change its presets field here from pallet rack to manual picking shelf to accommodate for a human. I'll hit OK. And now we can see again that the appearance of our shelf has changed. Now, another thing we want to do is we want to change the dimensions of our shelf. So on the right-hand side in the component properties, we have the bay width, depth, and height. Let's change the bay depth to 300 millimeters, the bay depth to 300, and the bay height to 200, like that. And now we can move our component, going inside this ring again, and dragging it close to its location over here. Now I'm going to zoom in using the mouse wheel. And what we still need to do is we need to rotate our component. And for this, what I'll be doing is I will actually hover over this ring that we can see here. So I'm not going inside the ring, but I'm hovering on the ring. And then holding down the left mouse button, I can rotate the component as we can see here. And what I can also do is I can hover over this little grid here, which allows for precise adjustments to its rotation. So I'm going to rotate exactly 90 degrees like that. And then I'm going to go inside this ring and drag the shelf over there. Now our shelf is in place, so let's zoom out and continue with locating our components. Next, we can pick the manual workstation from here, and I'll move it over to its place here down below. And again, I'm going to rotate my component, so I'm going to hover over this blue ring, and then using the grid here, I'm going to rotate it exactly 90 degrees like that. And there we go, now it's in place. Okay, and next we can move on to our CMM, coordinate measuring machine. So let's select our CMM. And there's one thing I want to show you before we locate this component is that it has this open face on this side. And we want to make sure that we have our component located correctly. And for this, instead of using this blue ring to rotate our component, I'm actually going to click on this component. On the right-hand side, we're going to change the rotation value here by entering into the RZ field 180, which will now flip our CMM machine 180 degrees. And after flipping this CMM machine, we can now go inside this ring and holding the left mouse button, drag our CMM machine into place like that. Then we can move on to our human resource, and our human resource Anna is standing over here. So let's click on her and put her in this location over here. And we can also take the human transport controller, which will be delegating the tasks of our human. And basically, this will be the brain of our human. So we'll take this controller and place it over here, like so. And then the same goes for robot transport controller, which looks very similar to a human transport controller, but it has this robot icon. So let's click on that. And this component, I'm going to position inside these two machines, or actually between these two machines. So place that over there like so. Next, we can continue on to place the conveyor on the right spot. So what I'll do is I'll select the conveyor and drag it into place. But we can now see that in the drawing, the dimensions of the conveyor does not match with the drawing. So again, with the conveyor selected, on the right-hand side, we can change its dimensions. So the conveyor length is going to be 3,500 millimeters. Conveyor width will be 300 millimeters. And the conveyor height will be 500 millimeters. Now we can see that its appearance and dimensions correspond with the drawing. I'm going to eyeball the position of the conveyor like that. And perhaps from the earlier part in this video, you remember that we had an in-feed conveyor going from left to right, and then an out-feed conveyor going from right to left. And what we need then is we need another conveyor. So I'm going to right-click on this conveyor, hit copy, and then I'm going to right-click again and hit paste. And now we can see that another conveyor appeared. And what is important to note at this point is that if I select the in-feed conveyor, this top conveyor, and I zoom in with the PNP tool still activated, we can see these interfaces here, these little yellow triangles on both ends of the conveyor. And these interfaces, these triangles, are something that we can use to connect other components to. But they also tell us which direction the conveyor flows. And as you can see that these triangles point from left to right, we know that this conveyor will also be flowing from left to right. We, however, want this outfeed conveyor here at the bottom to flow from right to left. So what we need to do now is we need to rotate this component 180 degrees. So I'll hover over to this ring here, this blue ring, and using the grid, I'm going to rotate the component 180 degrees, like so. And then we can eyeball its position based on the drawing, like that. Next thing we can do is we can actually connect our robot to the robot transport controller. And you might remember that I already mentioned that the PNP tool plug and play is not only for quick and easy movements of components, but it's also for connecting components with one another. So let's select the robot and let's bring it close to our transport controller, which is located in between these two machines. Now I recommend you to watch closely. What I'm going to do is I'm going to zoom in on these two components using my mouse wheel. And with the PNP tool selected, what you'll see in a second is that a green arrow appears between the two components, indicating that there is a compatible interface. And as I bring this component closer, based on the direction of the arrow, it will snap to place like so. And once I let go, these two components are now connected. So the robot is connected to the robot transport controller. If I now click on the robot transport controller, so I click on this pedestal, this robot transport controller, we can see that there's a green triangle indicating that these two components are connected and that the interface between these two components is active. Okay, nice. So from here, we can continue on positioning the rest of our components. So let's zoom out and let's locate the lathe component. For me, it's here. If you have trouble, however, finding this lathe component, you can head down to the bottom left in the cell graph option. And under the products and containers folder, you should see the lathe comp 1 component. And this component will be the product that is flowing throughout our simulation. And we can locate this component somewhere on the left-hand side of the shelf, like so. Now we still have the flow components that we need to position in our layout. And before we position them, I'll just give a quick kind of explanation of what these components do. So these flow components are helper components that are the material flow for our simulation. So they help us creating this dynamic product flow that we saw in the beginning of the video. And here we have 4 different components that we can see, all located under the flow components folder. The first component that we want to look at is this yellow component called the feeder. And this will be the source of our product. So this will be creating the lathe comp 1 component. Then we have the from conveyor process, which allows us to create material flow from the conveyor when we want to transport products from the conveyor. Then we also have the to conveyor process, which allows us to transport products onto the conveyor. And finally, we have the sync process, which is the end of our material flow where the products get removed. So these are the 4 helper components that allow us to map and create material flow in our simulation. Let's continue with positioning these products. So the first thing you want to do is select the feeder process like that. And I'm going to zoom out again in this case. And I'm going to place this feeder process to the beginning of our flow, which is over here, as you might remember from the initial parts of the video. Then I'll take this red sync process and position this component on the left-hand side of the manual workstation. And then I'm going to take the from conveyor process over here, drag this next to the conveyors, and the same for the to conveyor process. I'll take that and drag it also on the left-hand side of our conveyors, like so. Now let's zoom in to our to and from conveyor components over here. And as you might remember, we're going to have flow coming in on the in-feed conveyor and then flow coming out on the out-feed conveyor. And it means that we're going to need 2 of each of these components. So what I'll do, just like previously, is I'm going to click the component, then right-click, hit copy, and then right-click, hit paste. And then you'll see that the identical product appears or component appears on our from conveyor process. And then we'll do the same with the other to conveyor component. I'll right-click this component and then right-click again to hit paste. And now we should have a copy of both components ready to be connected to our conveyors. So again, with the PNP tool, we can connect components with one another. And you'll see that if I click, for example, let's start with the to conveyor process, it has these yellow triangles, which means that we can connect these to our conveyors. what I want to do is I want to connect this front triangle to our conveyor. So what I'll do, just like with the robot transport controller, I'll bring the component close, like so. And you can see that now that the green arrow appears, indicating that there is a compatible interface. I'll snap it into place like so. And we can now see that one of the triangles of this component turned green. We, however, want to ensure that the front triangle of our two conveyor process is connected to the conveyor. And what we'll need to do in this case is we'll need to redrag this component. So pull it out a little bit, like so, and pull it back in. And then the front triangle of our two conveyor process should connect to our conveyor. The reason we are doing this is we want to ensure that the output interface of our two conveyor component is connected to the in-feed interface of our conveyor component. Now let's continue on and also connect our from conveyor process to the other end of our in-feed conveyor. So I'll select one of the from conveyor processes and drag it again close to our conveyor, this time the outfeed or the output interface of a conveyor. And with the PNP tool again, I'm going to move the component close until it snaps to place, like so. And then I'll do the same trick as I did earlier. I want to connect now this input interface of our from conveyor process to the output interface of our conveyor. So I'll redrag this out a tiny bit and drag it back in. And now we can see that the input interface of our from conveyor process is connected to the output interface of our conveyor. Okay, nice. So now we've hopefully successfully connected the first helper components to our in-feed conveyor. Now we'll need to do the same, but for outfeed conveyor. And this time I'll start with the from conveyor process and drag this onto the out feed of our conveyor here. Redrag it to make sure that the input interface is connected. And then do the same for the two conveyor process. So let's move this close to the in feed of our conveyor over here. Watch it snap into place and then pull it out a little bit and put it back in to make sure that the two conveyors process output interface is connected to our conveyor's input interface. Okay, and at this point, we've completed the first step in this project, which is to create the layout for our simulation. And from here on, we can move to the next step, which is to create the material flow and the process modeling for our simulation. And to create the material flow for our simulation, we need to go to the process tab from the top over here. So the process tab, and in the process tab, we can create the dynamic component flow that we saw in the beginning of this tutorial. So make sure you're in the process tab, which you can see here from the top. And we'll start by defining the product that flows in our simulation. So I'm going to click on the product type editor. And now we can see that it revealed this product type editor panel here on the left-hand side. By default, we have this VC can, which we don't need. So click on the VC can, right click, and then hit delete. We can remove the default product there. And then let's click on the flow group number 1 again. Then click on this plus sign to add a product type. Now we want to edit this product type, and to edit the product type, you always need to make sure that you click here on the product type here, which will then in turn reveal the product type configuration here on the right-hand side. We can name this product type to be lathe comp 1, and then we want to hit enter to confirm that this is the name, like that. So now the name has been entered. And after hitting enter, we can select the component geometry, which will represent our product. So our lathe comp 1. And here in the component URI field, we have this little orange box, which reveals pick component from 3D World. So let's click this once. And then we can locate our lathe comp 1 here. And you should now see that this red bounding box encapsulates your product or your lathe comp. And once I click now on this lathe comp 1, you should see that the component URI has changed to component lathe comp 1. If this isn't the case for you, make sure you click again here on the left-hand side on the lathe comp 1 product, and then try clicking on this pick component from 3D World again. Now with this product defined, we also tell our feeder helper component to create and feed this product. So we need to click here on our feeder now. Click on the feeder. And then on the right-hand side in the feeder processes component properties, we need to go to the product creator tab here. And the product creator tab here, we need to go to the part field. And in this select part, we click lathe comp 1, which means that our feeder will now create and feed lathe comp 1. And now, if we go to the 3D world here in the middle and click on this play button, it will start our simulation. And you should now see that the lathe comp 1 appears on top of our feeder, which means that you've configured everything correctly. If this isn't the case, if you cannot see the lathe comp 1 on your feeder, then just go a few moments back in the video and check that you've done everything correctly. At this point, it's also very important to note that before we make any changes to our simulation, any change to the layout and so on, always need to remember to reset the simulation, which can be done from here. So every time you're making any change to the simulation, make sure you click reset. And the reason for this is that this can cause errors and problems in our layout later on. So it's always important to remember to reset the simulation. Okay, nice. So now we've done the first step in our process flow modeling, which is define the product which will flow throughout our system. The next thing we want to do is, as you remember in the beginning of the video, is that the material flow will be sequential. So we'll go from the shelf to the conveyors to the machines and back to the manual workstation and so on. So there's no parallel processes in this simulation, which means that we want to have unique names for all our processes. And in order to have unique names for all our processes, we can click here on the processes overlay button, which will reveal the location and the names of all of our processes. So now you should see these blue nodes and these blue process labels. And from the beginning, we can see that the to conveyor the name here is repeated twice, as well as the from conveyor name. So we're going to need to rename these processes. And we're going to rename the processes for the outfeed conveyor, so the bottom conveyor. And to do this, we can click on the to conveyor process label here, which then reveals for us the name over here, which we can edit. And we're just going to call this to conveyor 2 and hit enter. And then we're going to do the same. We're going to click on the from conveyor here. And we're going to name this to from conveyor 2 and hit enter like so. Okay, nice. So now we've got everything ready to start creating our transport links. The transport links can be created here on the top if we swap to the flow editor. And the flow editor allows us to map where our product flows. So make sure you have the flow editor selected. And after that, you should only see the blue process nodes. And now we're going to start to create transport links. And I recommend that you now follow closely my screen to see what I'm doing. And what I'm going to do is I'm going to first create a transport link from the feeder here to the shelf. And how I do this is I'm going to click on this process node here, and not on the label. So depending which I click on, there's different functionality. And in this tutorial, we're going to click on the process node. So I'll click on that. And what you'll notice is that the process node turns yellow, meaning it's selected. With the first starting point selected, I'm then going to hover over to this process node here and click on that, which will create us our first transport link. Okay, so I'll give you a few moments to create the transport link. And after you've created the transport link, what you'll notice is that the second transport node we selected or process node we selected is still yellow, meaning it's selected. So we can continue on to create a transport link to our in-feed conveyor, like so. From there, we'll create a transport link to the end of the conveyor. Then we'll create a transport link into the parametric vertical mill. Again, remember to click on the process node and not the process label. Then we create a transport link into our CMM. Back onto the conveyor, this time the outfeed conveyor. Then we create a link to the end of our outfeed conveyor. Then to the manual workstation here. And then finally to the sink, like so. And if you by accident create the wrong transport link, that is no problem. What you can do is you can click on the transport link and then hit delete, which will delete this transport link. Okay, and I'll give you a few moments to finish off the transport links. And if you haven't finished the transport links yet, feel free to pause the video. The next thing we need to do is we need to have the same flow steps here at the bottom in the same order as the transport links that we've created. So what we need to do is we need to now add the process labels here to the bottom, here in the flow steps. And how we do that is with the flow editor still selected, we hover over the node which reveals the label. We start by dragging this label to the bottom here, feeder label. Then we drag the buffer label down here. Then we drag the to conveyor label down here. Then we take the from conveyor label, the parametric vertical mill label, the CMM, the to conveyor to label, the from conveyor to label, and the manual process label, and finally the sink label. What you should also note is that you can reorder these processes. And this can be done if we click on this handle at the top of the process and then move it around. And now with our transport links and flow steps ready, we can close the flow editor from the top, which will hide the links. And in this first run, we're trying to see if the flow works without the resources, so without the human and the robot. And let's see if this works. So let's click on the play button. And what we'll see is that our product starts to move from the feeder to the buffer. And from the top, we can click this plus, which will speed up our simulation. And we'll now see that if we've configured everything correctly, the product should flow in the same way as in my simulation currently. So onto the conveyor, to the machine, to the CMM, and then to the manual workstation. And then finally to the sink. If not, then I recommend going a few steps back in the video and double checking that you've done everything correctly. If your simulation also works like this, then great, we can move on. But first, again, let's remember to first reset our simulation before making any changes. And the next thing we'll do is we're going to add our human and our robot to transport our products around the simulation. And one thing we need to do is we need to connect our human to the human transport controller. The moment Anna is not connected, and you can see that her shirt color is different to the color of the human transport controller. And what we need to do is we need to click on our human transport controller. Let me zoom in here, click on the human transport controller. On the right hand side in the human transport controller component properties, we'll click on the connect all resources button. So let's click on that. And now we can see that Anna's shirt color has also changed to cyan, which is the same color of our transport controller, confirming the connection. Okay. And now our human is also connected to the transport controller. What we need to do now is we need to go back to the flow here at the top, and we need to click on the flow editor, which will reveal our transport links. And now what to do is we want to change the mode of transport for these transport links. So what I'm going to do is I'm going to click on the transport link here, and holding down Control, I'm going to multi-select these three transport links. And so we have now these three transport links selected. On the right hand side, we're going to change the implementer from interpolating transport to the human transport controller. Then if you click on the floor, you can deselect these transport links. And now what we're going to do is I'm going to select the 3 transport links here next to the robot. Again, holding down Control to multi-select transport links. And then on the right-hand side, we're going to change the implementer from interpolating transport to the robot transport controller, like that. Now we should have all our resources connected and ready to start transporting our products. So let's start the simulation again. And we should now see that our human starts to move our product. And we should also see that our robot is moving our product from the conveyor into the vertical milling machine, into the CMM, and back to the conveyor. If your simulation, however, does not work past the robot, then I would double check that the CMM machine is facing the correct way, where we have this little door here. This door should be facing the robot. And the second thing I would check is that the robot is positioned in such a place where it is able to reach all these different points. Now, we might have noticed that when we run the simulation, that the human is actually walking through the shelf to pick our product. This is not what we want. And we also get this error message at the bottom here where our human is running into obstacles or disconnected areas. So let's look at a couple of things to fix these things in our layout. The first thing I'm going to do is I'm going to reset the simulation again. And the first thing we'll do is we'll change the pickup point for the human for the shelf. So what I'll do is I'll select the shelf here on the left. And the right hand side, we have the component properties for the warehouse shelf. Here we can specify where the resource should be when the product flows out. So the flow out resource location. What we'll do is we're going to set this to be -1000 in the TY field. -1000 in the TY field. So we change the side, and the RZ field here, we're going to change the rotation from -90 degrees to +90 degrees, like so. And now we can see the new location of the flow out resource location. So it's changed size from the left to the right. We also want to configure these for the nodes here on the conveyors. And what I'll do is I'm going to select this 2 conveyor process node. The right hand side, we're going to change the resource approach from right. So we're going to change this from right to front. And then I'm going to select the from conveyor process here and change the resource approach from right to back. And now we can see that the 2 arrows indicate the new position where the human will be when they approach these process nodes. I'll give you a few moments to configure those. And now what we can do is we have the output panel here at the bottom middle, which prints any relevant error messages or information that we need to know. You can hover over this output panel at the bottom, right click, and then hit clear, which should empty this output panel. Then there's a few more adjustments that we want to make. So let's zoom out here. And the first thing we want to do is we want again to go to the process tab at the top. And we want to open the flow editor, which reveals the transport links. We want to change the priority of these 2 transport links over here to ensure that the human first empties the manual workstation before moving on. So I'm going to select these transport links, holding down Control. And then I'm going to change the priority from 10, which is the default value, to 1. And then hit enter. And now we ensure that the human first empties the manual workstation before doing any other tasks. Then we can close the flow editor from the top. And instead we open the processes overlay, which allows us to edit what happens at the processes. We want to edit what happens at the manual process here. So let's click on the manual process label, which should reveal to you this process executor window. We want to add a work statement after the delay statement. So let's click on the delay statement first. Here you can see. So let's click on the delay statement. And from the top right of this process executor window, we have this little grid. So let's click on this. And this reveals all the statements we can add to our process executor. From here, we want to scroll down to the miscellaneous statements group. The miscellaneous statements group, and we want to add the work statement. So we can see that the work statement has now been added. And with the work statement selected, we can actually edit the statement properties here on the right-hand side. And we want to change that the human does the work here. So we're going to change the controller field. So let's change this to be the human transport controller, like so. And now what we can do is we can click on the delay statement and hit delete to remove this statement, like so. And now our work statement should be between the state busy statement and the state blocked statement. We can now close this process execute window. And we can also close this process overlay button at the top. We don't need to see the process labels anymore. And let's hit the play button again to see what these changes made to our layout. We first see that human goes to a different position to pick up products. And we also see that the human places the products at a different location. It seems to be that the transport controller is still printing error messages about the movement of a human, although it's not colliding with any obstacles. If you want to disable these messages, we can reset the simulation one more time. We can click on the human transport controller. And on the right-hand side, we can disable this UseGlobalArea option. Disable the UseGlobalArea option, which will now stop the human from checking any global obstacles in the 3D world. And this will also stop the error messages at the bottom. What we can do now is we can again click on the output panel one more time, right click this, and then hit clear, which will empty it. Okay. And hopefully this layout works for you so far. If it does, congrats for getting this far until now. And the next thing we're going to do is we're going to start to optimize our system. And we want to look at how many products per hour the system is able to produce. And for that, we need to use the built-in visual component statistics. And for that, reset the simulation one more time. And let's go back to the Home tab at the top. From here, we can find the built-in statistics. And now what we're going to do first is we want to extract data from the sync component over here. So let's click on the sync component first. And then we can open our statistics dashboards from the statistics button. And this little statistics window should open. What I'm going to do is I'm going to resize this window from the bottom right just to make it a little bit more accessible. And what I can do now is with the sync component still selected in the 3D world, I'm going to select the one column, one row regular dashboard option. I'm going to click create. And now this window opens and I want to select what kind of chart. And for this, I'm going to select the production rate option, which now opens the production rate dashboard. And now what we want to do is we want to configure the right-hand side. We want to configure the data from option. By default, it's set to the last interval. So it will collect and show data for this 60-second interval. But we actually want to accumulate data over the whole simulation run. So let's change this to the simulation run. What we want to also do is we want to run this simulation for 1 hour. So in the middle here, in the simulation run panel, we can click this little cog. You can see here, click this little cog next to the reset button. And in the simulation runtime, this is set to infinite currently. Click on the custom option here and set the simulation runtime to be 1 hour, 0 minutes, and 0 seconds. And this means the simulation will automatically stop after the 1 hour mark. Okay? And now what we can do is we can move our statistics dashboard to the side here and hit play. And in this case, what I recommend you to do is to speed up the simulation a little bit. Perhaps say, let's say to 100 times the real speed of the simulation and see what kind of production output we get. Okay, so I ran my simulation for an hour and I get 55 production units. And remember, the goal of this exercise was to get 130 production units per hour. So we're going to have to make some changes to our system if we want to achieve this goal. And to be able to achieve this goal, we first need to identify where our bottleneck is. And the best way to do this is we reset the simulation and let's change the playback speed, let's say to about 10 times. And let's observe the layout and see what happens. So the first thing we notice is that a human starts picking products from the shelf. And we can see that the human is running around the whole time with a 100% utilization rate. And this is the first indication that our human might be the bottleneck. The second indication that our human is the bottleneck is that there's a queue of components building up on the conveyor and the robot is starved of any components. So what does this mean? We need more humans. For that, we first need to reset the simulation like that. And what we want to do next is I want to click on our human here. And what I'm going to do is I'm actually going to click on the duplicate button here, the clone button. And this will clone as a human, like that. So now we have 2 humans. And although the cloned human's shirt color is also cyan, we still need to connect it to our transport control again. So let's click on the human transport controller here and click on the connect all resources option. And now the second human is also connected to our transport controller. And again, we can open the statistics dashboard from the top and let's run the simulation again for 1 hour and see what kind of results we get. Okay, so for me, the production output increased to 89 units. Yours might be a little different depending how you're positioned. For example, the components. What I suspect this time is that the number of manual workstations might be the limiting factor. So what we're going to do is we're going to add another manual workstation to the layout. And for that, let's again remember to reset the simulation first. And what we'll do next is select the PNP tool. Let's click on our manual workstation component here. And click the clone button. And this will clone us the manual workstation. And we can place this manual workstation somewhere between our first manual workstation like that. What we also have to do is we have to map the transport links to our new manual workstation. So what we need to do is we need to go back to the process tab here. Click on the flow editor to show us the transport links. And we can see that this new manual workstation actually has no transport links. So let's create these transport links. And how we do this, I'm going to click on the process node here. Click on the process node here. And you can see it's turned yellow, selected. I'm going to click on the manual workstation node here. That creates the first transport link. And then finally to the sync, like so. You can see that the mode of transport is not with the human transport controller. So let's select both these transport links. On the right hand side, you can change the implementer from interpolating transport to the human transport controller like so. Okay. And now I'll click somewhere else just to deselect these transport links. And what I'll do next is I'll reselect these transport links here. Again, multi-selecting them, holding down Control. On the right-hand side, let's change the priority of these transport links from 10 to 1, and then hit Enter. And now we should see that we also have our new manual workstation in our flow. We can close the flow editor, and now the transport links are hidden. From here, we can go back to the Home tab, go back to our statistics, and let's run our simulation again for 1 hour. Okay, so adding another manual workstation did help, and my production output went from 89 units to 100 units. But we're still not at 130 production units. So what we'll need to do is we need to close the statistics window one more time. We reset the simulation, and I suspect we're still missing a human to be able to achieve the goal production output. So I'll click on the human, I clone it. Then I click again on the transport controller. On the right hand side, I'm going to click on the connect all resources button to connect the third human to our controller. Okay, let's run this statistics one more time. Click on the statistics button, and let's have our fingers crossed that we can finally achieve 130 production units. And we were able to achieve our target, our initial goal of 130 production units. Well, in fact, I'm actually missing one production unit. So what we could consider is we could, for example, move the shelf a little bit closer to our conveyors, but for now, this is good enough. We can close the statistics panel, reset the simulation, and there's a couple more things we can do to make this layout a little bit nicer, a little bit more visually appealing. And for this, we need to add another component from the electronic catalog. And the electronic catalog for visual components can be found in the Home tab here. And what we want to do is, again, we want to open the models by manufacturer folder. Here I'm going to open this little, I'll click this triangle to reveal the subfolders. And then I'll go down over to the visual components subfolder and find a folder called Facilities Factory. And in this folder, we should be able to find such a component called Fence and Wall Builder. So here we go, Fence and Wall Builder. Let's hover over that, and we can drag this into the 3D world like so. And with this Fence and Wall Builder, we can actually draw a fence very quickly into our layout. So what I recommend to do now here is in the 3D world, we have this T option here on the bottom left, which allows us to orient ourselves to the top of the layout like so. And now with this view, we can select the Fence and Wall Builder component again. On the right hand side, in the Fence and Wall Builder component properties, we have the Start Drawing option. And now I can see that this little green circle has appeared around my cursor. And now what I do now is, with the left mouse button, I click on points to create a square around my robot cell, like so. And after creating this square, we can click the Populate Components option here on the right. And what we'll see now is a fence has appeared around our robot cell. Now we don't need the Fence and Wall Builder component, so we can click this pink translucent 4 that you can see here, which selects the component. And then we can click the red cross to remove this component from the 3D world. What you might notice is that the conveyors are actually colliding with our fence. We don't want this, so we can change the parameters of this part of the fence. And what we're going to do now is we want to click on the fence here in the middle. And now I've selected the whole fence. And then I click on this part of the fence again, which selects just this part of the fence. With just this part of the fence selected, on the right hand side, we can change the stand height from 400 millimeters to 1200 millimeters, which leaves a nice gap between the conveyor and the fence. And last but not least, we can add one more thing to make this layout a little bit more visually appealing. So in the same folder in the electronic catalog here on the left hand side, under Facilities Factory, we can drag this factory hall component and drop it into a 3D world. And I can see that the factory hall has appeared in our 3D world. With the factory hall component selected, the right-hand side in the component properties, I'm going to change the hall length segment from 5 to 2. And now you can see that the hall size changed. And then with the PMP tool, I'm going to go around inside this ring and move this hall so that our robot cell is located in the middle. The manual workstations are also located in the middle. And at this point, we can hit Ctrl S to save our layout. And this concludes this tutorial. So there you have it. You have a layout that you can now show to your colleagues and your customers. Hopefully you have now the basic grasp of how to create layouts, visual components. In addition, you can also understand how to model process flow for these components, how you can optimize the system, use the built-in statistics, and then finally make the layout a little bit more visually appealing. Thanks for joining, and see you in the next one.